Hi, good morning everyone. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today we are going to discuss about the high frequency PCB design. Come, let's get into the topic. So, in an electronic device pushed to fast switching speed and high frequencies, PCB designers face greater challenges. Printed circuit boards, that is PCB, serving RF, microwave, and high frequency speed digital applications require specialized design practice to ensure signal integrity and avoid unintended radiations. High frequency PCB design checklist. Use less number of vias. The vias introduce distribution capacitance of about 0.5 picofarad. Reducing the number of vias can increase the signal speed and reduce possibility of data error. Via steps add impedance discontinuous, resulting in a signal integrity problems. Implement short leads between the pins in a high frequency circuit. The radiation intensity of the signal is directly related to the routing length of the signal line. Longer high frequency signals leads results in an increased coupling with other components. That is why a shorter routing length is preferred for clock signals DDR, USB, then gigabit and HDMI. Avoid trace bends if required opt for a 45-degree bend. This practice reduces the chances of emission and coupling of high frequency signals. Here, the very important note is circular bends are preferred over angular bends. So here we already discussed that is we have to avoid the bend. So the angle, how much angle we can consider, that is given in this diagram. Before you commence with a PCB design, it is a vital you have a design in mind. Doing this will help you to prevent anything that might cause setbacks for your design. Having a checklist is an important way to go about this. So here there is analog circuit, digital circuit, power circuits, low frequency circuits, connector, and everything is there. So all the categories, analog, digital, all the categories we can go for the PCB design. So, but the consideration should be very carefully we have to consider. Make sure you determine the voltage and power demands for the integrated circuits. Design if you will be dividing any power planners. You also need to check if different signals can be accommodated. The manufacturer helps to ensure what the requirements for minimal tolerance rate. It is important you have a plan of how to reduce the noise level on your high frequency signals. Immediately you plan how to design the PCB, it is important to write down the demands for the stake up layer. So you can seek the help of manufacturer to know the specified material for your PCB. It is important you understand the specific constraint and materials for your printed circuit board. So everything which is given in this diagram, that is a standard here it is a standard, and when it comes to the floor planning, you have to divide your PCB into sections. You need to determine if you will be replacing your sub-circuits into a bigger design. This is important where when there are digital and analog sections that need to be carefully isolated to reduce the interference. So here the floor planning diagram is given over here. So floor planning is the fundamental thing. Before going to make a design in the PCB, we have to make a floor planning. So floor planning in the sense like we are building a home, we are going to plan first, right? Where we are going to keep the kitchen and dining room and bedroom like that. So likewise for on a PCB also we have to section wise we have to divide and we have to plan what are the things we are going where we are going to place. That and all is called as a floor planning. This is the important step. After you have defined the PCB layout, you need to examine your HDI PCB design. You need to understand the ground plane. You may not have to divide the ground plane using a routed signal. High frequency PCB often features small pad. Their pads are smaller than that of other PCB. Reducing the PCB space helps us to ensure the PCB is useful. You can also maintain the pad size to match the component pin size. Reducing the space comes with several benefits. This will maximize the parasitic capacitance, increase the mechanical strength. If you reduce the space, there will be a more space for various pairs. If you want to get more shielding benefits of this board, you need to route your frequency signals, high frequency signal to produce a high radiation. There can be an interference between two separate signals due to this. Routing the frequency signal can help you to prevent this from the happening. And high frequency PCB applications are being used in advanced communication systems, military industry, radar systems, medical systems. So these are the applications of the high frequency PCB design. So thank you.